Hello out there in Symmetry land. This is Saturday of the first week. I guess this is day 6, and we are going to go to the moon. We're going to do rocket science in Symmetry, and we're going to start off with a lesson on three-dimensional vectors. While we wait for a few more people to join the live stream, I'm going to kind of build out the space in a way that lets us kind of see some more depth, get some depth perception in here. So what I'm going to do, set my VR headset aside, what I'm going to do is put some pyramids out in the space here. So we're going to go to cone, and we're going to draw some pyramids. By pressing, you'll see here that you can see the central axis of our world, the up Y and the outer Z and the X direction off to the right. If you press G to toggle that off and on, you can see it. You can also see, I'm not seeing the human scale toggle here with H, but you should be able to, at home, get H to show you a human scale. So I'm going to draw a cone, which means an outer radius first, a height next, a top radius by left-clicking again and pulling down. And before I release it, while I'm still kind of haven't committed, I can scroll my center mouse wheel down and get to increasingly fewer sides, and I'll get down to this three-sided pyramid, and I'm going to make a bunch of these, and with their upward face, we're going to be inspired to go to the moon here. We change some of their scales and get kind of a little landscape we like here. Actually, that guy is gonna. Oh, yeah. I've enabled this space. One of the only changes I made to it is I took gravity out of the equation. We'll bring gravity back into the equation in some interesting ways a little later, but for the time being, to demonstrate, I'm going to demonstrate something in a second here. So gravity is at 0, but when I press play, which actually looks kind of nice, I get these things jump out into the air a little bit and kind of hover there, which is fine. Otherwise, I could kind of pin them to the ground, which I might do. Pin them in space using selecting them all and going to the rigid body and making it not movable. So movable set to false. I'll do that for another selection here. Movable false, and this last one here, movable false. And I'm going to kind of change some of their colors a little bit. So the things that we're going to be working on today are going to be physics, well, obviously scripting in Lua. We're going to do some physics and math, which are obviously very interwoven. We're going to be working on three-dimensional vectors, and I've got a little demonstration that can kind of give you a good intuition for that. And when we share this show, with people after the tutorial, that you can go then and download. You can go in here and kind of mess around and play with this little vector toy that I'm going to show you. Yeah, so I'll finish up the last of these and look at my technician in the booth. Good to go? Yep. Cool. So let's do a lesson here. This is going to be a really fun one. You're going to be able to get a lot out of this. So in earlier lessons, we built an attractor which pulled on objects in the space. It created a force every frame that the script ran, 90 frames a second while in VR, and it pulls a little force kind of proportional to the distance and in the inverse direction of some object to some object. So if just the way kind of that gravity works, kind of like a gravity, kind of like a magnet, slightly modified. And on our second day lesson, we made an interaction where we pressed a button. We clicked a button in the space, and a little rocket kind of just shot up, and it shot directly up in the air. And you'll recall that was shooting up with a force in the upward or Y direction in the world frame, the world's frame of view. It went in the upward direction, that was a vector of 0 in the X, 1 in the Y, or something in the Y, some amount in the Y, and then 0 in the Z. And so that was a little introduction to vectors and forces in both of those. We're going to use the attractor in today's lesson, and we're going to do some flying around space and kind of set up a little crazy kind of gravity outer space world that should be pretty fun. So there's a lot of little components to do. The basic one that we want to get an intuition for is the vector 3. And so what I'm going to do is do a little demonstration here now that can give you an intuition for how a vector 3 works, a three-dimensional vector. So I'm going to jump into VR to accomplish that. I'm in VR mode up here using a Oculus Rift, but you could follow along on Windows Mixed Reality or Vive. Yeah, so with that, we're going to check this out. So I've also set this up so that you guys can see out in the monoscopic view, so that you're not seeing my left eye and my right eye. So you're seeing now what's in the VR headset. I'll try not to make it nauseatingly shaky as I go into the world. I'm going to grab my controllers, summon my hands in front of my face, and this is living on top of the preset rig. This is just the VR, on the VR toolbox of VR rig, your basic rig. And I put a little thing over on my hands, and you'll get the sense for this. This is essentially the vector. This is the transform frame. That's a useful term. The transform frame. So if you went and looked at this object and looked at its transform under its properties, you would see that it is, if this is 0, 0, 0, you see that it's up in space. But any children of it, anything else, has a new frame of axis. As this moves around, this takes with it its own coordinate system. So right here, this is 0, 0, 0 of the world. This is forward in the Z direction over here. If I point my fly button, I fly out into the Z direction. I'm putting it over my shoulder. I'm pointing backwards to fly back to 0. If I want to go into the right direction, my right direction, that's the positive X direction, and the negative X direction, I can actually fly under the Earth and come into this magical liminal. It's not exactly the upside down, but it's still the right side up, but it sure is underneath. So it's the negative Y and the positive Y. Cool. And again, looking at the hand, my hand is in the world, with respect to the world transform frame. It is in the positive, it's now in the positive X, the positive Y, and the positive Z zone. It's positive X, positive Y, positive Z. So it's up here. And then if something were living in this thing's frame, if I was looking at this object, and it was, say, my left hand now, my left hand is now in the positive, 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 the positive X, positive Y, and positive Z frame of this object, until I do this. Until I do this, now the left hand is sitting in the positive X, positive Y, and negative Z of frame of my right hand. In the frame of my right hand, my left hand is in positive, positive, negative. But in the frame of the world, it's still in positive, positive, positive. That's the way you kind of want to, it's one of the ways you can kind of think about these vector 3s, or these three-dimensional vectors. And here's another demonstration. So this is 0, 0, 0. Just like my hand, I've got this vector. This is the vector that is pointing from the 0, 0, 0 to some amount up here. And I could have printed that out. That would be very doable. But I've got this dynamically updating these little arrows down here. So you can see each of these are what are called component vectors. And what this means is that the red is showing you how much this thing is, how much X-ness is in this sphere's position. Oh, it's quite a bit of X. In fact, it's mostly X. When I go straight out on the X axis, it's all you really see is one red guy. And maybe our math was not quite right, 'cause it's not quite following it completely, but that's our issue. You get the idea, though. In general, we're pretty close here. We put this together pretty quickly for this demonstration, but the idea being that this is the amount of X-ness that's out in this position. This green one is the amount of Y-ness, right? And this is the amount of Z-ness right here. And what's kind of cool, too, is that, this is the world transform frame, but what if this thing moves? Oh, all of a sudden, when this thing gets to here, and they're now on the same plane, the same y level. This one's now at, say, a ½ meter up, and this is at a ½ meter up. There's no longer any green vector. There's no green arrow, right, when they get to the same. So that's a 0. This vector right here is just basically 0. This white vector would probably be something like 0, x, and y, z. Like, sorry, excuse me. This would be something x, 0, y, so 0 green, and something z. And again, this one should be exactly lined up. That's our little math error, but we won't make that math error in the lesson. We just put this together here. So there you go. So this is like a visualization of that vector, and imagine now this thing, we've moved it to the other side. We've moved our base black vector and now our white vector, or sorry, our base black point and our white point. Now our black is out in front of it, and this vector points in this it's downward and leftward direction, and downward, leftward, and backward. Whereas here the vector is forward, upward, and rightward, downward, backward. Okay, cool. So that's 3D vectors. This thing's fun to play with, to get an intuition. We'll go check our little where we made a little calculation there and fix it before we upload it. Yeah, this thing is great. You want to get your brain, you want to fill your brain with this thing and understand this, because what we're going to be doing is adding forces to objects. Now, I didn't make this ball grabbable, so if it's under interact toolbox interactions grabbable, so I can't grab it when I laser over it. But I did make a little function on my right controller button here with my nice coordinate system. That basically when I press my index trigger, I'm going to add a force to the rigid body of this thing in the direction. And remember, there's no gravity. I can fly up with it. And if I point down, I'm adding a force in the downward direction. So this is now, based on this principle here, I can kind of send it in the direction that I'm pointing from kind of anywhere that I'm pointing. So if I point back here, it goes there. And this is kind of like, this is what all the astronauts are dealing with in space, is talking to ground control and running calculus operations or whatnot to figure out how to get back to some place based on these forces. So they're constantly, once this thing gets going, you're constantly trying to figure out how I can deal with the vectors that's on it, because when this thing's moving, it has a velocity vector on it. It's moving in a certain amount of force in this direction. It'll eventually slow and kind of come to a stop. That's sort of symmetry's equivalent of air friction or something. It'll bounce off this. But when it's moving, and I press to go in this direction, it doesn't go directly there. It ends up averaging the two, essentially, where it was heading in prior and where it's getting the new force. So it takes its current velocity and it kind of integrates this new velocity into it. So if I want to steer it to the side, I can steer it to the side by pointing and adding these forces. And so this is actually super fun. I can imagine that the basis of this alone could make a game where you kind of have to navigate something through a maze using just your hand. Summon it back to myself here. Come up to it, point it down. I imagine if you played with this for a weekend, you'd get pretty good at it. Okay, so this is the basic premise. Now, what we're going to do with this ball, and I'm going to show you the script on this, and this is the script that we're going to kind of be working with. Basically, what's happening is when I press my right index button and I point it in a direction, like say this matching, say this vector, like the black to white, that direction. When I point in that direction and I press my index trigger, I'm saying, hey, go get the rigid body, the physics representation of that sphere, and go and apply a central impulse to that for the moment that I'm pressing it in that same direction. And you can see that it's flown off in that direction. So if I want to bring it back, I'm basically just going to reverse course. It's almost like Dead Reckoning in like Flight. Oops, I'm a little off, but... And then I can maybe slow it down. Come back, come back. I'm shooting over my shoulder to bring it back. And this is why rocket science is rocket science. And you'll get a real cool intuition for it when you play with this, when we upload it for you. Okay, so what we're going to do is take this principle, the principle of this, what I'm doing to this sphere, and then I'm just going to attach myself to this sphere. In fact, I'm going to attach myself to it right now, and you're going to get an idea, and then we're going to build it from scratch. What do I mean attach myself to it? I'll show you right now. So I hit escape, escape, and I'm back now in stop time. And here's the sphere that we can that we're controlling with our right hand. And I'm going to show you the script that's on my right hand. It is under right hand, so under the VR rig. That's so VR rig. That's the headset and the two hand controllers. There is a script under. So if you go to VR rig and expand it on the right hand, if you expand it again, expanding it on the index trigger of the right hand, expand it. There's a script node. A node with object script that carries up these, and we're going to learn about how these base level VR interaction systems work here today. It kind of carries up, and anything that's on here will happen when the index trigger is pressed. So this is happening when the index trigger is pressed. We'll take a look at this code. We're going to edit that code, and you're going to recognize some of this stuff from the past lessons, from the attractor. Let me just narrow this down so we can take a look at it. So this is called node on pressing. This is the on pressing event for the index trigger, and it basically gets it gets rolled up kind of into everything on this right hand. We'll explain a little bit more later, but this is the pressing event for my. This will be one of the pressing events that's going to happen for my right index trigger, and all I'm doing in this is getting a hold of my sphere. So this is sphere N82. I got that by dragging in this. So that's the sphere, and I basically say, you can ignore this just for the moment. I basically say, okay, go get the sphere, get its rigid body, that physics body, which we've done in the past couple lessons. We're going to apply a central impulse in the self get world look at direction. So this is kind of one of these. This is one of our little magic scripting lesson introductions here. This is going to be the direction of myself. So this index trigger, this thing's going to live on the right hand, wherever the right hand is pointing. What it's looking at, that's the forward or Z direction. That's the on my hand, the blue. You can see that. See the blueness. See the blue in the laser lineup. Red, green, blue, X, Y, Z. So the relative Z direction of that controller. So that's the world look at direction. That's the direction that my hand or my controller is looking at. So wherever I'm pointing, basically. And then times val. What is val? And what is scalar? So val, when I'm pressing my index trigger, the thing that the event gives me is this little thing called val. It says, hey, you're going to want this. You're going to need this variable. This is called an argument in script. In a function, it does what's called passing in arguments. This is like, hey, this is feedstock for the calculations in here. This is stuff that is going to be useful. What is val? Val is a 0 to 1 float variable. Float meaning it's a pointing. It's a floating point variable, meaning it's 0, 0, 0, 0, 1, 0, 0, 0, 1, 0, 1, all the way up to 1. So it's 0 to 1 with all these decimals in between. And what that means is that when I apply this force and I press just a little bit on the index trigger, I only apply a little bit of force. So I take, in this direction, I'm pointing, I'm saying, give it, just a little bit. When I press it at 0.001, and then by the time I fully press it, I give it the full amount. That's fully 1. And so that's useful, and you'll find that a lot kind of in script, is and especially in these interactions that you'll go from kind of 0 to 1, and then you can choose what the effect of that needs to be, and that's where scalar comes in. And what I mean by scalar is, okay, when I just go 0 a little bit, that might not be the amount of force that I want. In fact, what I ended up doing was I started with the scalar equal to 1, and then I pressed play, and I pressed my controller button, and the ball went flying. And I'll show that to you now, which is that, in fact, let me just make it even 0.1. You'll see that 0.1 is going to be ludicrous speed. So here I am. This is my look at direction, my look at dir of blue, and I'm going to press the index trigger just a little bit, and I fully press it, and it's off. It's out into outer space. So that's why I've included scalar. And scalar, sometimes programmers call these magic numbers, but they're meant for you to get your ultimate user interface and your experience kind of dialed in. And so I dialed it in by going from, I started it actually at 10 and it was stupid, and so then I went to 0.1, it was still stupid, and so then I went another 1/100th of that and I dialed it into I think 0.001 is where I ended up. Is that right? Yeah, that's kind of nice. So I have more control over it, but there's different, that kind of thing is really up to you. Maybe you do want it to shoot off into outer space, and maybe you want to even control, maybe at some point you want to change what scale is. So let's jump back into that script. That script again is under the VR rig, under the right hand, under the index trigger, on this blast off script. And so yeah, so maybe you're creating a game where you level up and you need to increase what scalar is, but you'll know how to do that. If you've looked at the past several lessons, you'll have an idea on how you might do something just like that. Okay, so we're going to attach ourselves to this ball and go for a little bit of a rocket ride on our own, and you're going to see it might get a little crazy when this thing collides, when this sphere collides with objects, because we'll go rotating with it as well. And so we're going to do something to fix that. But let's go for a ride on this ball and get a sense of what we're going to be, how we're going to be able to build to this. So what we need to do is put our VR rig onto this sphere. And what I'm going to do is I'm just going to place it on in the hierarchy first. Let me close down this group. In fact, I'm going to get rid of this group. This group no longer exists. Excuse me. Just cleaning up the space. I'm also going to take these cones, just clean this up, and I'm going to hit Control E, and that just collapses them into a group. And I can say cone group. There we go. Now it's a little clear. We'll call this blast ball. So we're going to put the VR rig onto the blast ball, and I'm going to do it on the hierarchy first. And this is a very common thing if I'm going to sort of unite a couple objects. But I'm going to put the VR rig, I grab it on its words, drag it down, you see it sort of selecting. When I get down to, not cone group, excuse me, blast ball, I'm going to release it, and now we've got a child. The VR rig is childed. Now I want to get the VR rig like centered on this ball. So the way that I do that is select the VR rig, and under transform, this is no longer the world frame. Remember what I was saying in the beginning? This is now, since it's a child, 0, 0, 0 is the center of the sphere, not the center of the world. It's the center of the sphere. So you can do that. Child something onto some other object. Select the object, the child, and I was double clicking these scroll wheels. You can also select and set to 0 here, and you can 0 it. And then let's say you like where it is, but you want to go up or down. You want to sort of center yourself in different positions. Maybe you want to be slightly back. That'll be negative in the Z direction or something. So you can control that, but for the time being, I'm just going to make it, I'm actually going to put it just a little bit in front of me. Excuse me, I'm going to put the VR rig slightly back so that the sphere is slightly in front of me. And I'm going to go slightly down, so it might be easier to look at this thing in front of me, look at the sphere. So it'll be sort of at my like knees or my waist. And let's take a look. So now we are on this sphere, and this could get dangerous. I mean that kind of jokingly. Yes, there it is, down kind of at my knees. And I'm pressing my right index trigger. You can actually see it depressing here. We've designed the rig to be animated. And now, instead of this fly, I'm actually going to not use fly in my left hand any longer. Instead of like flying where I just set my position discreetly, where I tell my VR rig to go where I want it to go exactly, I'm actually just adding force to my parent object. I'm adding force to this ball, and I'm just following it, which is kind of a cool way to move around because it's very fluid. It definitely makes me feel kind of. This one has a different magic to the movement. I really like it. Now we're gonna, if I hit this ground, we're gonna go for a tumble. So, hang on to your lunch. It's just like doing a million somersaults as a kid. So we're tumbling, and I don't really like what's happened here. So I don't want this exactly. So I'm gonna solve that, where instead of this parent-child situation, I'm gonna actually have this sphere tell my my VR rig where to go, which will be interesting. So how do you do that? First of all, let's not do the parent-child. I wanted you to see what that's like. That's a total awesome option, but the collision situation means you go rolling with it. What I want to do is actually when the blast ball goes moving, I want it to tell my my VR rig to move into that position. So what that means is we're going to use a piece of script called get world position and and set world position. So the blast ball, when it moves, it has an event, and we've been learning about events, right? So we come up here under the top level, and on events, you can see here, this one's happening every frame. On tick, that happens every frame. That's happening a lot. On move happens if and only if the ball is moving. Well, what's causing the ball to move is the force injected from my right hand script, which we were just looking at. And what that means is that when it moves, this move event will be called. So when it moves, I want the VR rig to go with it. So let's take a look. We're going to click on move, and we're going to create an event here. And this one will be pretty simple. So what we're going to do is get a hold of the VR rig, because we're going to tell it where to go. And we already know we can also use our function self to get a hold of ourself and get our own position. And so the way that this will work is we're going to basically set the position of VR rig like this. We're going to say VR rig, typing it just how it was, written above, VR rig, set world position, open close parentheses. So this needs a vector 3, just like we've been talking about. So where do we want it to go? Well, we want it to go where we are. So we're going to say to our self, and this is get world position. So when we, what does this return? Self get world position. Well, if we called that right now on the blast ball would return negative 0.1284 0.568 comma negative 4.38. That's its position at this moment. And as soon as we add some force in one of these directions, it's going to start flying off into across a whole bunch of new positions. And every time it moves to a new position, it's going to call this code, and that means it's going to go and get the VR rig, and it's going to go set the VR rig's world position to its self's new world position. So the VR rig tells the ball where to go by force, and by physics forces, and the ball is going to tell the VR rig where to go by setting its position. Okay, let's give this one a shot. This may be. Let's see here. Okay, we got our control. The sphere is directly under me. It's like literally at the center of my VR space at my feet, which means that basically the VR rig is always centered to that place that you've set as your world. It's always centered to that place that is your VR center when you calibrate your system. And so now I can like collide into objects and doosh. So now I'm kind of like the spirit of a bouncy ball or something. And so this whatever you want, whether we're gonna build a rocket or whatever, this is the basic premise. We're gonna travel on our satellite, let's just say, our spacecraft to the moon. Very cool. This is really enjoyable. I'm just sitting here enjoying this a lot. And yeah, the ball is, we can make the ball even bouncier. All of its physics is totally active, and it's just getting it's just getting impulses from my hand. So this is the first of the major demonstrations, and now we're going to basically set this up in a world where we're going to set this up in a different type of space. We're going to set this up in outer space, and we're going to do two more cool things, which is to bring kind of a moon and an Earth with different gravities into the picture, and this will be our locomotion mechanic. This is kind of fun. All right, well, I have to stop playing with it. Okay, so I'm gonna actually save my show at this moment. Escape, coming out of VR mode. I'm gonna save here. And what we're going to do now is set up this scenario from scratch. We're going to do it live from scratch, and we're going to introduce you to outer space. What is and how do we create outer space? So you've been introduced up to this point to what's called terrain space. Lives under the universe. This is what's considered kind of the universe and space hierarchy. This is terrain space. Terrain space is the overall parent that we're looking into through our viewport, through our camera. We're looking into terrain space. We're flying through terrain space. It contains all these objects. But there's other spaces available to us in this, symmetry show or universe. We'll talk about symmetry shows and universes. What's the right word for that? We mean the same thing, basically. Obviously, the show is kind of like the scenes that you've composed and everything, but you can also think of the container as the universe. The universe also contains different things in the sort of universal, higher-level ideas and objects, like your displays. These are the outputs to other things. The universe kind of contains these. They live across all the different spaces, and what this means is that the universe is your top level, and then you have spaces underneath. So we can create new spaces by right-clicking in this pane right here underneath terrain space. If we right-click, you can see we've got a screen space, an open space, a terrain space, and a sky space. Well, we already really know what a terrain space is. We could create another one of those. Sky space is a space with gravity but just doesn't have a terrain, which is interesting because that's actually what is behind. That's actually what's behind your terrain space now. If you click on the sky, you're actually looking at a separate space, a sky space, and you can actually right-click and hit Edit Contents, and oh my gosh, there actually is this sky space that exists back here. And if I put a cube in this space and I go back to the terrain space viewport, this thing lives, that giant cube lives off in sky space, and I can't. I'll leave it up to you to try to fly out to it. But it lives at a different scale off in the distance, and the atmosphere renders in front of it, which is really cool. And it's a way you can build really awesome looks. But that's a sky space. So that's the sky space living on. You got your terrain space, you got your sky space. we right-click to hit Edit Contents to go into there, or you can create a new sky space and drag that, excuse me, you can create a new sky space and then drag that onto your terrain space's horizon. The horizon is the property that is attaching, that's the attachment between the terrain space and the background, is this horizon. And if you put a new sky space or open space and you create it over here and drag it onto here, you'll see what happens. It renders in the background, which is super cool. But today we are going through sky space. Let's just imagine we fly off terrain space through sky space and we go to open space. When you create it, now you just double click it and you're in open space, and it is a black world. You can see a grid across the bottom, even without, well, yeah. So if you press G, you'll see a grid kind of rendering along this space. And this is where we're going to build. We're going to rebuild our flying VR contraption, and we're going to build an Earth and a moon and give them different gravities and kind of like fly in and out of their orbits. And we can build some stars and stuff. So that's where we go today. So let's dive into that. Let's first rebuild our basic craft, our shuttle, whatever we're calling it, our orbital. No, orbital's not the right word. So what we're gonna do is we're gonna build our blast sphere. As you notice in one thing I want to show you, I'll just give you a little demonstration of sky space. VR is still rendering here. I need to turn off VR, and then
there's a VR rig, so it's going to switch to that view. So you can just do file new. That's probably the easiest way to start this one.
Okay. The VR rig wants to carry me back to terrain space, so I'm actually just going to save where we are. We're going to do file new and just start a new screen space. Once I've put a VR rig over in the other space, it wants to start there.
If you create a VR rig in this space, it would keep you in here.
Yeah, I could create a VR rig in here. Let's just do that.
Okay.
All right. If I put a VR rig in here, in this space, no.
Okay.
Thank you for your patience. We're going to do file new. You would basically, we're not going to teach that lesson right now, but the way that you can switch through, you would have to just do one line of script that can like toggle between the viewport that you want to render into. Anyway, not for today's lesson. So what we're going to do is make a new, we're going to start with a new universe and a new terrain space, and we're going to create a new open space. Double click on new open space, and in here I'll demonstrate how the open space works. First of all, if you click anywhere in the space, you're going to see physics. Gravity is already at 0, 0, 0, so there's no downward force gravity, which means that these objects are kind of moving along freely. And if you control click, you can kind of pivot on, do the right. Oh, here I should. Let's turn on the key callouts. Forgot to do that. What are those?
Developer?
Yeah. Edit, developer. Display input callouts. There you go. Sorry I didn't have that on. Forgot to do that one. So you can now see I can rotate around that, which I find really helpful. That's the right mouse button held down, and then hold down control and move your little center reticle onto some object, then hit control. Then you can pivot around it. It's sort of, I think of it almost like a pole vault, like a fishing pole, like snagging. Fishing pole's not quite right, but snag that object and rotate around. I find that to be really helpful in this space. And of course, W, A, S, and D keys while holding down the right mouse button still you fly around. In this one, you will find yourself going underneath objects a lot more. So be forewarned. Also, if you press H, you can see what's going to be human scale, which is kind of key for VR if you want to make things larger or bigger than yourself. So I'm going to hit escape, fly back in towards these things and kind of see how big they are in comparison. So I would say that this object is technically as big as, this is exactly one bread box. No bigger, no smaller than a bread box. That is exactly a bread box, and now bigger than a bread box. So if we're going to have like a little magic carpet, a rocket of some sort, let's go with the sphere. I still love the sphere. So we're going to build our device, and we're going to make it, we're going to understand. Once we get like one object in place, we can kind of once we get one object in the right scale, we can pretty much base off of that. We'll use that as a man is the measure of all things. Once we've measured one, we'll be able to go from there. So if I were to make kind of like I don't know, like a yoga ball sized object, and I'm gonna make it glow because I feel like it should be glowing a little bit. Make it glow just a little, not too much. Otherwise we'll need sunglasses. So this will be we'll name it too. So this is going to be named we'll call it Rocket Rider. I don't know. So rocket, what about Rocket Glider? Rocket Glider. Alright, so we're going to use Rocket Glider. Rocket Glider is going to work in combination with our VR rig. So we're going to use actually a blank rig instead of the preset, and we're going to work up from there. All right, so our VR rig, and the VR rig you see actually kind of comes in exactly about human height. So now that we've got this, we can probably get rid of human scale, and I'm going to leave grid show by G, but I toggled off human scale with H. I'm going to leave G on. So let's see here. The first thing that we want to do, we're not gonna do the childing. We didn't like that because if it bounces into, and we're gonna put some objects in here that we're gonna bounce into, and that could send us spinning. So what we're gonna do is what we did last time: set the position based on where the rocket glider goes and how it moves. So the first thing is to create the script under the right hand, and we're gonna place it on the index trigger. And so there's a couple ways to do it, but a fast route is actually to use over here under VR. What we're going to do is just kind of set up a little node called press to fly, and then we're going to delete out the script. So this is a way that you can this is a shortcut. So I've clicked press to fly under VR AR, press to fly, and we're going to go to under the VR rig, under the right hand on the index trigger, and you see it's kind of purple selection, and we're good. So now we have this thing called fly, and the other thing that's happened is our index trigger is ready to receive. It's ready to receive these nodes of script, and so this is where your script is going to live, under here. So if we right click to hit edit code, this is where we're going to apply the force to the sphere. So we're going to edit code here, and we're going to actually just delete all this out. But this is, if you wanted to inspect it, this is the code for that the preset fly locomotion mechanic, and it also uses a get world look at dir, but it just places the VR rig's position. It sets the VR rig's position in some offset from its current position, in an offset based on that world position, and then again one of these little magic numbers, or this is the amount that I'm pressing, and this is kind of the meters per second is the speed, so that's our magic scalar. So again, you've got a scalar kind of magic number, you've got the value, which is the amount coming from the button, and it's just based on the pointing direction of my hand. So we're actually going to get rid of this, but I just wanted to show you that those same principles are applying. So what we're going to do is we're going to put a force on this sphere in the direction that we're pointing. So in order to do that, we need to get the ball, the rocket glider, into we need to get it into this script. So we're going to drag it in by its icon, and we've got rocket glider equals this. So we need to get its rigid body, get a hold of its rigid body, and apply a central impulse. pay attention to the fact that this is happening every frame while we are pressing our index trigger. So on pressing of the index trigger, we're going to apply some force to the rigid body of the sphere. So the way that this is going to work is rocket glider colon get rigid body, which returns the rigid body. So now we can run the function apply central impulse. And this needs a vector 3, and we're going to give it a very particular one. We're going to give it the position. We're going to give it a vector 3 that is the where I'm pointing the world look at direction of my right hand, and I can accomplish that by typing self, which is essentially the index trigger. And then typing get world look capital A T. I always forget to make that capital A because sort of look at sounds like a one word. Get world look at dir. And then I have a vector that is the like I showed you before, where the blue part of that axis on my right hand was pointing that laser, that forward direction. So wherever I'm pointing this, I'm going to make this rocket glider take that force. And I'm gonna because I want there to be more force when I have when I press the button more. Remember, this goes from 0 to 1. I'm gonna multiply this by val, which means that if I'm pressing it and I'm pressing it a little, I will only go a little bit in that direction. And if I'm pressing it and I'm pressing it a lot, I'll go a lot in that direction. And then my magic number, my scalar, and I'll just say it's just scalar, and this just scales the amount of the effect. And I'm going to actually just sort of repeat what I did last time. So I need to, scalar doesn't exist yet, and it actually, syntax error, it doesn't like S. It wants me to do something. Scalar doesn't exist yet down here until I type it. So I'm going to type, excuse me, mouse got stuck. So scalar equals, and in this case I think I'm going to do what I did last time, which I think is just 0.001. And so what that means is the sphere is going to move in the direction that I point. And if I hit VR, we'll see if it moves where I'm pointing. When you hit VR and you're in with Rift, I need to press a button to... Okay, I'm here. Oh no, that worked. Go overpressed it. Quit app. Symmetry. Loading.
Watch out. Oculus.
Yeah, it doesn't want it.
Looks like Oculus killed Symmetry. Oh, there we go. Yeah, I'm not sure what happened there. Oculus is... Yeah, the stream is getting weird.
It's stuck in the home. It's stuck in the Oculus land. The Oculus menu.
Yeah, I think OBS has stopped streaming correctly. Okay. Stream health.
We'll take a pause. We'll be right back. We think the OBS has hiccuped.